Now we've moved the value into HH handle, it's time to use our handle to write to the console. So the first thing we have to do is move into RCX, the handle. You could have done RAX here, but since we moved it into the variable, we might as well use our handle. We've moved that into RCX. Now the next parameter which WriteConsole needs has to go into RDX. That's just the convention. So what does it want? WriteConsole wants a buffer, a pointer to a buffer. A pointer to a buffer that contains characters to be written to the console screen buffer. This is expected to be an array of either char or WriteConsole A for WriteConsole A or W char T for WriteConsole W. Since we're not using the W version, we're going to have to use char. Char is 1 byte, so we're going to be using define byte for our message. So what we'll do is in the data section, we're going to write MSG for message to define byte. Now we do open and close quotes, and we can write what we write. I love ice cream. And after this, we put a comma and we put 0AH, that is the hex code for a new line. And then we have to end all of this with a 0, a null terminating byte. Because when the program tries to print this, it needs to know when the string ends, and it's going to use the null byte, the 0 byte, to stop itself. It'll know that this is where the message ends. So we've got our message, and we need to move a pointer to this message into RDX. We need to move a pointer into RDX, and the way to do that is load the effective address into RDX of MSG. It's going to take the start address of MSG and load it right into RDX. Now, what is the second thing it needs? It needs a D word, which is 4 bytes. Number of chars to write. Now, if you wrote 1, it would only write the first letter of our string. If you said 2, it would write the first letter, I, and then the space. So you want to write the whole thing. So you need a D word, 4 byte space, which is holding the number of characters to write. And the way to do that is very simple. In the data section, we'll write a variable called mLength, and here we will define it as a D word, which is DD, define D word, because that's what the function expects. DD. Now, how do we get the length of the message? We use the $sign. This will tell the assembler that we want the address of mLength. Remember, all these labels are just for you. For the computer, these are addresses. HChannel is an address. MSG is an address. mLength is an address. A 16-bit hex digit represented address. And it doesn't have to use all the bits. All the digits, but it consists on a 64-bit system of 16 hex digits. So this is basically saying take the mLength address and subtract it from MSG, subtract it from the address where MSG starts, and this will give you the distance between MSG and mLength, which will be the entire number of characters we want to write. And that is stored into mLength. And this you want to move into the third register. The third register where the third parameter needs to go into is R8. But R8 is not going to work. If I do R8 and then I do mlength, you are going to get an error for size operand mismatch. Here, as you can see, instruction operands must be the same size. R8 is a 64-bit register, or 8 bytes. mlength is a D word. It's 4 bytes. It will not load it into this. So let's break the R8 down. We'll change it. We'll use its 32-bit portion, which you can access by just adding a D right after the 8. You can do this with all the R8, R9, R10, R11, R12, R13, and R14. You add D to them, and now you can move a D word into them. Pretty cool, isn't it? Now we've loaded R8D with mlength. What is the next parameter for WriteConsole? The next parameter is the number of bytes written. This is an optional parameter. It says a pointer to a variable that receives the number of characters actually written. I mean, choose to skip it. We won't. We'll use it. And it's a pointer to a D word, so we need to define another D word, which is 4 bytes. In our program, if I can get to my program, and we'll label it C written for characters written, and we have to do DD for define D word, and it's uninitialized because we're not going to do anything to it. The WriteConsole is going to do whatever it wants to it. That's why we have an out here, because this signifies that this parameter is going to be filled in by the function as opposed to the ins, which you need to provide filled in. So this is a D word, and again we want to move this into the R9. That is the 4th register. That is the 4th register where the 4th parameter for Windows APIs must go into. So to do that, we could use LEA for load effective address, because we want a pointer to this. We don't actually want it. We want a pointer to it, so we need to use that. Or you could just do move and R9, and you would do offset C written. There you go. Now at this point you may be wondering why using R9 C written is a D word. Shouldn't you be using R9D? Well, no, because we're loading a pointer to it, an address which contains C written, which points to C written, sorry. And addresses and pointers are always 64-bit or 8 bytes. So had we actually been loading C written into R9, we would add the D, but since we're loading its address, which is always 64 bits, we'll use R9. Finally, the last thing is LP reserved must be null. Now, we've already used up 4 of the registers. Now the 5th argument for a function has to go onto the stack. So the first argument you're going to put onto the stack has to be above this 32. And to do that, you will do move RSP plus 32, and then you would move the value of 0, which is null, into it. RSP 32. RSP will add 32. RSP has the address of the stack. It'll add 32, and these brackets are telling it to put the value into there. Now if you try to do 0 right here, it's not going to work. It's going to say invalid instruction operands. So what you have to do is first move it into a register, and you can use any register, just don't use one of these registers because they have to be sent to the function. I'm just going to use, because I feel like it, R14. So I'm going to move 0 into R14, and then I'm going to move that into RSP plus 32. Now we're done pretty much. Now we have to use call WriteConsole, and this should work. I can spell it. Well, there's a better way to do this, isn't there? I just copy paste it from here. As programmers, you're supposed to be lazy. There we go. Get rid of this proto. Now let's try running it and see if it works. We have an error. Undivide symbol. You see what I mean? I can't spell. And I still have an error. Unresolved externals. WriteConsole. Yes, we don't want WriteConsole, we want the A version, so not the W version. And if you do this, now it should work. I love ice cream. So there you have it. That is how you would use WriteConsole A. Yes, you have to use WriteConsole A. I don't know why it doesn't say A here. It should say A here. A is for the ASCII string versions of functions. If your function isn't working and it has a W, like we read here, well, it does say WriteConsole A here, so yeah. It actually tells you, but generally functions have an A version for the ASCII strings and a W version for the wide characters. So, but here in the documentation, they'll just put it into WriteConsole. You need to have enough sense to know that if you're using the A version, you should put down A. Like I told you, I'm pretty dumb. Anyway, so that is all for this video.